Calculus. A function is defined as the relationship between two variables, for example variable x and y. If we look at this equation, y equals x squared, this is a simple parabolic function. Now I'm going to plot the values for x between -3 and +3. When I put -3 into this expression, -3 squared will give us 9. -2 squared will give us 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. X is said to be the independent variable. What I mean by that is that we give x a value and y depends on that value. So y is the dependent value. So for example, if x was 10, that's the independent variable. We put x into here as 10. 10 squared is 100. So the dependent variable y is 100. The x values are called the domain and the y values are called the range. Calculus. A function is defined as the relationship between two variables, for example variable x and y. If we look at this equation, y equals x squared, this is a simple parabolic function. Now I'm going to plot the values for x between -3 and +3. When I put -3 into this expression, -3 squared will give us 9. -2 squared will give us 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. X is said to be the independent variable. What I mean by that is that we give x a value and y depends on that value. So y is the dependent value. So for example, if x was 10, that's the independent variable. We put x into here as 10. 10 squared is 100. So the dependent variable y is 100. The x values are called the domain and the y values are called the range. How differentiation works. For the curve y equals x to the power n, we can use that now the rule dy dx is n times x to the power n minus 1. We want to differentiate in the first one, y equals x cubed. So dy dx will be 3 times x squared. Notice the 3 comes in front and the power gets decreased by 1. The next one, y equals x to the power 10, dy dx will be 10x to the power 9. In the third one, y equals x. dy dx, because that's x or x to the 1, that will be 1 times x to the 0. Remember, anything to the power 0 is 1, so that's 1 times 1, which is 1. So in other words, when we differentiate x, we will get 1. In this one, we're looking at y being equal to a constant 7. If we consider that to be y equals 7 times x to the power 0, because x to the power 0 is 1, so we're not changing that 7 because this is 7 times 1. When we differentiate this, we get 0 times 7 times x to the power -1. Notice we decrease this power by 1. 0 times this quantity is 0. That gives us the rule basically that when we differentiate a constant, we get 0. This one we want to differentiate 1 over x. Now that's the same as x to the power -1. So dy dx will be -1 times x to the power -2, which is -1 over x squared. In the last one, y equals 5x to the power 4. dy dx, we leave the 5 at the moment, and multiply that by 4x to the power 3, which is 20x cubed. Rules for differentiation. In the following examples, we have u and v are both functions of x. Our first rule is this, that if y is u plus v, two different functions of x added together, then dy dx is du dx plus dv dx. In other words, differentiate the first one plus differentiate the second one. Sometimes this can be remembered as u dash plus v dash. Here's our example. Y equals x squared plus x to the power 5. Dy dx, so we differentiate the first one, the 2 will come in front, and the power gets decreased by 1, so that's 2x, plus 5x to the 4th. In the next one, y is the square root of x minus 9. If we consider that be y equals x to the power a half, that's the same as the square root, minus 9. We differentiate this one first, so that will give us 1/2 x. When we decrease a half by 1, we get negative a half. When we differentiate 9, we get 0. That's exactly the same as 1/2. X to the negative 1/2 is the same as 1 over x to the half, which is 1 over the square root of x, so this becomes 1 over 2 square root of x. In the last example here, y equals 2x cubed plus x to the negative 2 minus 7. Differentiating each one in turn, this we leave the 2 times 3x squared plus negative 2x to the negative 3 minus 0. This will become 6x squared minus 2x to the negative 3. Calculus integration, finding the primitive. When we differentiate x squared, we get 2x. 2x is called the differential function. X squared is called the primitive function. When we differentiate x squared plus 7, we get 2x when we differentiate x squared. 0 when we differentiate 7 is the same answer, notice, 2x, the same differential as in part A. Therefore, when we differentiate x squared plus any constant, we get 2x plus 0, which is 2x. Hence, the primitive of 2x is x squared plus c, where c is any constant. Remember, when we differentiate x squared, we get 2x, and when we differentiate c, we get 0. What does this mean? If we draw the basic curve y equals x squared, we get this parabola coming through 0. When we differentiate this, we get dy dx, and when we differentiate x squared, we get 2x. dy dx is the gradient of the tangent at any point x on this particular curve. If we were to look at the next curve, y equals x squared plus 1, it's the same basic parabola shape but moved up the axis 1 unit. Also, when we differentiate x squared plus 1, we get 2x plus 0, which is 2x, the exact same differential as in the first one. So what we have in this first one, when x is equal to 2, we can find the gradient of the tangent at the point 2 by substituting 2 into this x value, which will give us 2 times 2, which is 4. What does dy dx means? It means the gradient of the tangent at a specific point. If we want the gradient of the tangent to y equals x squared at the point where x equals 2, it will be 2 squared or 4. In this different curve, but with the same differential, when x is equal to 2, dy dx is also 2 times the x value, which is 4. What does that mean? The gradient of the tangent to y equals x squared plus 1 at the point where x equals to 2 is also 4. The formula for the volume of a sphere is given by V is 4/3 pi r cubed. It's possible to prove this formula by using calculus. If we were to look at a circle, centre at the origin, radius r. The equation of this circle will be x squared plus y squared equals r squared. Now, if we were to change the subject of this formula so that y squared was the subject, it would be y squared equals r squared minus x squared. In other words, we're taking away the x squared from here and from here, thus creating a hemisphere. And we're rotating this hemisphere around the x-axis from 0 to r. Our volume will now be pi times the integral from 0 to r of y squared dx. Y squared's already in the form of r squared minus x squared. So our volume will be pi times the integral from 0 to r of r squared minus x squared with respect to x. Now when we integrate r squared dx, we will get r squared x minus the integral of x squared is x cubed on 3 between the limits of 0 and r. The top limit in first, which will give us pi times r squared minus r, which is r cubed, minus r cubed on 3 minus the bottom limit in, which will give us 0. R cubed minus r cubed on 3 is 2/3 of r cubed. Multiplied by pi, our volume now of the hemisphere is 2/3 of pi r cubed. Hemisphere is half a full sphere, therefore our volume of the full sphere is 4/3 pi r cubed, which is the proof of that formula.